Hello students, myself Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So in this session, we will discuss the question bank tutorial on the engineering materials. So this is the third module we have. So here we will discuss the questions, how they appear and how to answer. So first one is, why cannot thermosetting plastics be reused and reshaped? So the word itself indicates on heating, it will be setting to a deformed shape. So when it is deformed, it cannot go back to its original shape. So we cannot reuse it again, reshaped again. Why is this happening? This is because of the bonding that is present. So the intermolecular forces are very cross-linking. Intermolecular forces are cross-linked. So these are present very closely in between the polymeric chains. The polymeric chains. So between the polymeric chains, if you see, there is cross-linking always present in the thermosetting polymers. So when compared to this thermoplastic polymers. So whenever there is an increase in stress or heating, then there is a scope for the reshaping it to the original shape for the thermoplastic because they are weak. But in thermosetting, they cannot be deformed, and once it is deformed, it is not able to go back to its original shape. So these thermosetting polymers are soft and malleable at low temperatures. So at low temperatures, we can do like they are soft in nature. But what happens whenever we heat or at high temperatures, they become hard. So they become hard and we cannot retain their shape. So this is because these polymers tend to form cross links between these polymeric chain when heated and becomes hard and strong as a result. So this is something like chemical change is taking place. Chemical change is taking place, so we cannot reverse it back. That is, irreversible reactions are going on. So the bonds are very strong. This is why they cannot be remolded by heating them again, and they would only get charred and would not be softened back. So this is how the thermosetting plastics natures are. So they cannot be reused and reshaped back to its original shape after heating. Next one, PVC is soft, flexible, whereas bakelite is hard and brittle. Why? So PVC is polyvinyl chloride, polyvinyl chloride. So this is formed by polymerization, and bakelite is a resin formed by condensation, polymerization. So PVC is a homopolymer, like it is forming from the vinyl chloride monomer, that is the repeating unit of PVC. So only one single monomer is used and therefore forms polyvinyl chloride. Whereas in bakelite we use like two different monomers, and so it is copolymer, phenol and formaldehyde. So if you see, this is the structure for PVC and this is the structure for bakelite. So the bonding between these is van der Waals forces, and here they are covalently bond like with becomes rigid in nature. So in PVC, the molecular chains are bound to each other by van der Waals forces, and hence these long chains are flexible. This becomes flexible in nature because of these van der Waals forces present between two PVC chains. And can slip and twist on applying force. But in bakelite, what happens? It is a thermosetting polymer. This is also thermosetting polymer, bakelite. So they are cross-linked by covalent bonds. So covalent bonds, strong bonds are present here and they are rigid in nature. So cross-linked together and they form hard and no deformation can take place even upon applying any force. So what happens in PVC? They are flexible because of these van der Waals forces that are present. Van der Waals forces that are weak in nature and can deform easily and go back to their original shape. But in the case of bakelite, covalent bonds are formed and therefore it is rigid in nature. Even upon applying pressure, no deformation takes place, like going back to its original shape, it will break, it becomes brittle in nature. So that is how the bakelite and PVC varies in their properties. Next, why do all simple organic molecules do not produce polymers? So polymers, to produce polymers, what is the major criteria? The should have the monomer should have reactive functional groups. So whenever they have reactive functional groups or the functional groups attaching, then only the polymerization reaction takes place. So if at all there are simple molecules like CH2 H6 or C2H5Cl or the C2H5OH like ethanol, so these have only one functional group. So monofunctional groups cannot form longer chains. These cannot form longer chains. Longer chains. They cannot form longer chains. So whenever there is no formation of longer chains, it means that polymerization does not occur. So the main thing, another one is like the carbon chain is more important for the polymerization reaction. So the more and more carbon atoms are there, the bigger and bigger chains will be forming. So this is how the network polymers are also forming. So for polymerization, an organic molecule should be at least bifunctional. It means two-way, it should have the functionality, and therefore simple monofunctional organic molecules like these cannot use for the polymer formation. They cannot produce polymers. So for example, like this. And also state the monomers used in making polyvinyl chloride and nylon 66. So this is nylon 66 structure. So if we see here, polyvinyl chloride is the PVC. Okay, so I have already told like vinyl chloride is the unit that is used. So this is the monomer used. So polyvinyl chloride is many vinyl chlorides together kept, and addition reaction takes place like polymerization and forms a polyvinyl chloride. But in the case of nylon 66, what happens? Nylon 66. This is the structure of nylon 66. Here hexamethylene diamine is condensed with adipic acid. So CH2 taken 6 times, NH2 and NH2. Hexamethylene diamine. And adipic acid is CH2 taken 4 times, C double bond O OH and C double bond O OH. So it should also have the carboxylic group for the reaction to take place. So if you see here, for example, both functionality is in both ways. So it is having a carboxylic ending group. So adipic acid and hexamethylene diamine take part in condensation reaction, eliminating water molecule. So therefore it is condensation reaction taking place and forms nylon 66. So there are different monomers used. So this is a copolymer, and this is a homopolymer. PVC is an example for homopolymer and nylon 66 is the copolymer. Next, why thiacol rubber cannot be vulcanized? See, this is the structure of thiacol rubber. So for vulcanization, what we do, we treat with sulfur. So for adding sulfur into the carbon chain, what do we require? We require unsaturation in this chain. So this is not present in the case of thiacol rubber. So therefore we cannot vulcanize this thiacol rubber. The presence of double bond between carbon atoms as in natural rubber is necessary for vulcanization of rubber. These are not present or absent in thiacol rubber. So that is why we cannot vulcanize thiacol rubber, whereas we can vulcanize the natural rubber and form vulcanized rubber. Next, natural rubber requires or needs vulcanization. Why? Because This natural rubber is very hard in nature. So they once we add sulfur and heat it in the presence of sulfur, they form crosslinks. So sulfur is present here. So whenever it is forming crosslinks with sulfur, it will form like improve the elasticity so that we can use it for more and more applications. So here the main purpose of vulcanization is to improve the elasticity of the rubber at high and low temperatures. And sulfur is heated with rubber to introduce the cross-linking and thus forms the tougher forms of rubber. It increases the elasticity but also is very much useful for the wear and tear purpose. For example, in tires, in the automobile tires, what happens? It is exposed to wear and tear. So even though it is elastic in nature, it is forming a tough rubber. So that is how both the ways it is useful. Therefore, vulcanization is very important for the natural rubber before it is used for any of the applications. Then, if you see this question, describe the preparation, properties and uses of bakelite. So this is a direct question, but sometimes it can be asked like, what are polymers, synthesis, properties and applications of phenol formaldehyde. So what is this phenol formaldehyde? This is nothing but bakelite, formation of bakelite. These are the monomers they have. Monomer is given here. So two monomers are given, that is a formation of bakelite and PVC, polyvinyl chloride. The question can be asked whether directly like bakelite or phenol formaldehyde, that is the monomers for the bakelite. So what happens in the bakelite? The condensation reaction takes place between the phenol and formaldehyde in the presence of acidic or alkali catalyst at proper temperatures and produces bakelite resin. So what happens here? If you see here, this is the reaction phenol and formaldehyde. So what happens here? The elimination of OH minus ion takes place and there is always scope for ortho and para substitution of these CH2OH. So CH2OH. So it can form either this or both. Both. So depending on the ratio of this phenol and formaldehyde. So initially phenol and formaldehyde reacts to produce mono-trimethyl phenols based on the ratio of this phenol and formaldehyde ratio. So it can form either ortho-positioned or para-positioned or metaposition. Metaposition will be here. So it can form both or any of these will be forming. So this is further condensed together to form the next stage of resin. So what happens? The first is the formation of mono, di or trimethanol phenols that are heated. So in the second is they will be heated together to form a straight chain of methanol group with the hydrogen atom of benzene. So what happens here? Now for example, OH, CH2, OH. Then we are again condensing with the same. Then what happened? The hydrogen atom of benzene ring is reacting here. So there is elimination of water molecule from this. So then what happens? It will form OH, CH2 and CH2OH and here again OH. So this is intermediate A. Okay, so this is the intermediate A. Whenever we take many, it forms a number of molecules like in a straight chain. So when again, if there is condensation between methanol phenol, then again there is a formation of another compound like this, the intermediate. So what happens here? Now the CH2OH group, this is reacting. So the hydrogen from this is para and this is meta. This para and meta groups are active here. So they will be reacting and elimination of water again. So again there is formation of bond between CH2 and this OH and CH2 and this will be remaining as such. So this is another stage B. The stage A and B again will condense together. These two again react together and form a big rigid bakelite. So this is the structure of bakelite. So if you see here, these chains are again joined together. The CH2 will be as such, and there is elimination of oxygen with like water only. And here also they are all connected with the covalent bonds. Covalent bonds. So this is how a bakelite is formed, and it is rigid in nature because of covalent bonds that are forming between the polymeric chains. So different chains are joined together with these covalent bond. So next is the polyvinyl chloride. What are polymers? Explain the synthesis, properties and applications of polyvinyl chloride. So if you see polyvinyl chloride, first the vinyl chloride preparation is important. So we use acetylene, and in acetylene it reacts with HCl and forms vinyl chloride. CH2 double bond CH and chloride. So we have seen in the differences like for addition polymerization, they requires unsaturation or the double bonds in the monomers. So here we have that double bonds because we are adding monomers together. So whenever we are adding monomers, they should have sufficient electrons to donate. So therefore it requires unsaturation in the monomers, and it is active in the catalyst or free radical mechanism takes place. Free radical mechanism, benzoyl is forming a free radical, and there is addition of these vinyl chloride and forms a polyvinyl chloride. So if you see this, this is the polyvinyl chloride structure that is forming a very big structure, again bonded with van der Waals forces between the polymeric chains. These are the polymeric chains. There will be van der Waals forces between these chains like this. Okay, so polyvinyl chloride is obtained by heating vinyl chloride in the presence of benzoyl peroxide or hydrogen peroxide under pressure. So this is how the polyvinyl chloride will be forming. So it has very wide applications in our domestic and also in the industrial applications. Next, what is condensation polymerization? Explain the preparation, properties and engineering applications of nylon 66. So nylon 66 is also one of the type of copolymer forming because two different monomers are used here. So what are they? Hexylene, hexamethylene, hexamethylene, diamine and adipic acid. So this is CH2 taken twice, NH2, NH2 and adipic acid, adipic acid, CH2 taken 4 times, C double bond O, OH and C double bond O, OH. So the structure contains both. So they condense together, eliminating the water. Water will be removed in the elimination reaction and forms the nylon 66. So this is a copolymer with adipic and hexamethylene diamine monomers, and these are in turn obtained by the butadiene. So these are obtained from the butadiene molecule. So this is the reaction that takes place. So this is the adipic acid, hexamethylene, hexamethylene, diamine. Okay. So what happens here? So whenever it is H2, we can write it as H and H here. Instead of writing H2 like this, we can write H and H, right? So now the water molecule is removed like this, H2O. Okay, this also, like instead of writing H2, we can write H here and H here. So this water molecule is also removed. Fine. So in the two ways, water molecule is removed, and the remaining is C double bond O, CH2 4 and C double bond O, and NH is remaining, CH2 taken 4 times and NH. Okay, taken n times because polymeric chain. So in this way, elimination of water takes place and forms the nylon 66. So it is having many polymeric chains, and they are connected by these hydrogen bonding. Hydrogen bonding. Strong hydrogen bonding that are intermolecular forces occur between these polymeric chain 1 and 2 connected by this hydrogen bond. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.